What comes to mind when I say science class? I wasn't the kid who enjoyed reading science books, but I loved the days in class when science became tangible. I still remember the excitement and curiosity of dissecting owl pellets to learn about the anatomy of their prey, testing rocks with white vinegar to identify calcite, and observing crayfish in the ecosystem my classmates and I built for them. Hi, everyone, and welcome back to Beyond the Breakthrough, where we talk with experts about key contributions to scientific discoveries and technological advancements. I'm your host, Kelsey Underwood. Did you have a similar answer to me? Well, we tend to remember hands-on engagements and sensory experiences more than textbook material because we're in the driver's seat, making the discoveries in real time. And thanks to technology and education research, these experiences are becoming more accessible, more immersive, and in many cases, even more extraordinary. How are new technologies changing the way students experience science? And how do you make the universe hands-on? And what is the impact of new experiential learning? This month, I sat down with two experts working at the intersection of research and science education, Tiffany Stone Woolbrick and Rachel Freed, to find out. We talked about how school science and real-world science differ, how students can observe a dark sky during the school day, and how viewing the cosmos shifts how students see themselves. Before we begin, please note, Our Place in Space is an interactive undergraduate-level astronomy curriculum developed with support from the U.S. National Science Foundation and AUI. Student research was made possible by the Skynet Robotic Telescope Network. The Las Cumbres Observatory also supports student research through its own program, Global Sky Partners. Any opinions, findings, conclusions, or recommendations expressed are those of the speakers and do not necessarily reflect the views of the NSF or LCO.
It's kind of unbelievable when you're sitting in your little town in California and you take a picture with a telescope in Spain and then you see a galaxy in the screen.
This is exactly what students do when they participate in the Global Sky Partners program with the Las Cumbres Observatory, where Rachel Freed serves as the Santa Barbara Education and Outreach Coordinator. She's also the president and co-founder of the Institute for Student Astronomical Research, a nonprofit that helps students get involved in astronomy research and publication. The Las Cumbres Observatory operates a network of 27 fully automated telescopes across 7 sites in the United States, Chile, South Africa, Australia, and Spain. Working together as a single instrument, the telescope network allows both students and professional astronomers to remotely observe the universe.
Our sun is in our sky half the day, blotting out all of the stars behind it that we can't observe. But you can access a telescope remotely in Australia when it's nighttime there. And so that is really great for professional astronomers who do optical astronomy, but it's also good for students because they can collect their own data using a telescope on a mountaintop in Australia, get that data and explore the universe in real time with their own hands.
Tiffany Stone Woolbrick is the Deputy Director of Education and Public Engagement at AUI, where she works on various STEM education and public engagement initiatives, including Our Place in Space, an undergraduate astronomy curriculum developed at the University of North Carolina, Chapel Hill, with support from the National Science Foundation and AUI. The program allows students to remotely operate telescopes through the Skynet Robotic Telescope Network and analyze their own astronomical data. Tiffany is also researching middle school robotic telescope curriculum as a doctoral student at Charles Sturt University. Seeing stars and celestial objects on the other side of the world is, of course, incredible. But robotic telescopes also help solve several practical barriers that teachers and students face at every level of education.
The sun, light pollution. If you're in a big city where there's lights all the time, you aren't going to see the stars even at night, or not many of them. The weather. I live in Ohio where there's over 300 cloudy nights per year. And also telescopes, can be expensive.
So what exactly changes when students go from learning science in theory to doing it themselves?
Research has shown there is a big discrepancy between sort of the traditional ways of teaching science and the way that science is actually done in the field. When students are able to actually work through the lesson themselves to solve their own problems, to follow their own creativity, that you have more effective learning outcomes.
There's sort of the motor memory involved. All the senses that you can get involved in learning enhance the memory and the retention of material.
But sensory engagement is only part of the equation.
A couple of things are something we call transformative experiences, which is relevance to normal life. So if you can tie a lesson for a student to their home, to their community, to their interests, they're more likely to remember it. Also, novelty is a big component. And then there's social aspect as well. Science does not happen in a vacuum. And in fact, some of these larger discoveries that we're accomplishing collectively require sometimes thousands of scientists or other people that aren't even scientists that have different skill sets and different solutions, different backgrounds. And those people all come together to make that big science possible. And having students working together is another way to sort of demonstrate what that looks like in practice.
The Global Sky Partners program and the Skynet Telescope Network give students a chance to experience this kind of collaboration firsthand.
I love the Global Sky Partners program, and it really does highlight that science. It is very human, it is very community-based, it's very collaborative. And I think there's a misconception with science, it's one man in a lab coat, or it's one astronomer looking through a telescope and he's alone, he's writing in his journal. It's just not how science is done anymore. And I think the truth of it is much more exciting. It's global, it's huge, it's collaborative, and you're always learning something new from people around the world.
Through the Global Sky Partners program, the Las Cumbres Observatory dedicates more than 1,000 hours of telescope time annually to educational organizations, reaching tens of thousands of students. Rachel has guided many educators and students through the Telescope Network software, teaching them how to remotely control the telescopes, capture images, and analyze the data. Rather than working directly with every student, Rachel and her colleagues help train educators and program leaders around the world, who then bring telescope experiences to students in their own communities. Today, the program has 30 partners across the globe, including Australia, Brazil, Ukraine, Italy, and Nigeria, just to name a few.
And one of the amazing things is the way that the different global sky partners help each other out. I mean, it's really a global network of not only telescopes, but the community. I taught an amateur astronomer who wants to be a professor someday in Nigeria. And then later I taught 2 students in Ukraine. And I then saw a paper that they wrote together, a research paper they did. And I just thought that was really cool.
Participating students have written nearly 150 peer-reviewed publications since the program launched in 2017. For many students, though, the most important outcome is confidence.
We've seen self-efficacy. That's the students' sense in their ability to do something. And that seems to be where robotic telescopes can really make students feel like they can do science, they can do astronomy, they can use these really complicated instruments and collect their own data and analyze and understand the universe on their own terms. And that's been really powerful.
Tiffany found similar results, especially among girls during her Our Place in Space work.
Something that we've seen in our research with undergraduate students is, and this is consistent across STEM fields, students will enter into a classroom with girls in particular, really low sense of self-efficacy. After the intervention, after the curriculum, the self-efficacy scores between boys and girls were effectively the same.
In surveys conducted before and after telescope activities, Rachel and her colleagues at Las Cumbres Observatory also found that many students began to see STEM careers differently.
We did some pre and post questions, and a lot of them all of a sudden were like, oh, I want to be an astronaut or an astronomer. It opens up their minds. If they have not experienced this kind of thing before, it really opens up the possibilities for them. Like it's something they didn't even have in their awareness.
And that impact may depend on when students first encounter these experiences.
If we go back a little further or earlier on, like in middle school, where you are starting to think about what do I want to be when I grow up, and that is still really malleable, perhaps a really cool experience like working with a telescope could shape someone's perspective.
But before students can build confidence, teachers need confidence too.
Early adopters are pretty easy to get, so we have like a small network of really enthusiastic, incredible teachers, but that challenge of how do you then expand that more broadly. So that's something that we are looking at, and that's something that I think technological advancements, software advancements, things like that could support.
Using professional grade software and technology can be intimidating for teachers who may not have a background in the field. To help lower this barrier, the team at Las Cumbres is working to make the Telescope program interface more user-friendly for both teachers and their students.
The students use the same interface to control telescopes as the professionals. And for some, that can be intimidating. There's a lot more on the interface that they would never hear the terms or know what they mean. And so LCO has developed a sort of a student-friendly portal, which really simplifies that.
Another challenge robotic telescope programs often face is reaching the students who could benefit from them most, those who don't already have regular access to technology and learning resources.
I work with places that might not have regular electricity, and then how do you have your Zoom calls, and how do they control a telescope remotely from the internet if electricity is intermittent? And that's still going on, and that's still a problem.
And behind many of these challenges, from teacher training to technology access, is another ongoing issue: funding.
So sustainable funding for education initiatives continues to be a problem. Education is generational. It is by definition a long game. And so 3 to 5 years of funding, if you're lucky, is just not, it's not sustainable in terms of building a network and a program that's going to last and to affect generational change. It can't just be a spark. It needs that continued support, that community, and that network of people and resources.
What a great conversation with Tiffany and Rachel. No matter how many times I think about the distance that is virtually traveled to make this student research possible, my mind is blown. And technology doesn't only make the telescopes function, but also unites the community necessary to make research and learning possible. If you're interested in learning more about robotic telescope learning opportunities, you can visit the Las Cumbres Observatory website at lco.global/education/partners, and the Skynet Robotic Telescope Network site, skynet.unc.edu. We have some great resources on robotic telescopes and education linked in the show notes as well. To stay up to date on the latest AUI breakthroughs and news, follow AUI at Discover AUI on Instagram and Associated Universities Inc. on Facebook and LinkedIn, or visit aui.edu. If you'd like to be notified about new Beyond the Breakthrough episodes and bonus content, be sure to subscribe wherever you're listening. And if you enjoyed the show, please consider leaving us a review to let us know. That wraps up today's episode. Thanks for joining us, and I will see you next time.